failure of his vascular system, not circulatory, it doesn't circulate. At this time, this is not what's being talked about, but, and the result is this extraordinary compound demonstration of the canal systems in the human body, with the urogenital system as well. It's a drawing that ultimately collapses under the weight of its own graphic ambition. Undeterred, Leonardo says, make it from the side and the back as well. Leonardo is not always alert to the limits of what he's doing, which is part of his fascination, but also does explain some of the unresolved ambitions in his work. You could look then at the microcosm, the human body, and he talks here in the notes about the basic findings are transferable without too much problem. And he got very interested in the aortic valves, the three-cusp valves. Less interested in the mitral valve, which is the two-cusp one. And in this drawing, this big double-folded sheet, I've put in an isolated, I've inset a drawing of the isolated valve to give you some idea of how it was. And Leonardo realized it was passive. No muscles in this valve. Therefore, it must be operated by the blood itself. And it's operated by the blood going into the constricted neck of the aorta. While I was looking again at these, I was contacted by a professor of biodynamics and aeronautic engineering at Caltech called Maury Garrett, who was interested in building a model of Leonardo's valve because Leonardo said do it himself. The drawing here, which you can see in the top right, the Leonardo drawing, this is his declaration of intention to build it in glass as a model. Very fantastically innovative way of proving something. And in the lower area, you can see his hypothesis that the vortices curl back into the cusps, blood goes poof through, hits the constricted neck, curls back in these ionic vortices, snaps the valve shut before the next thrust. Maury built it in glass, put these floppy three cusps in place, and then used modern imaging techniques to see what was going on, which you see in the bottom right-hand corner. Of course, Leonardo could see none of this, but what he had done is to transfer knowledge, as we would now describe it, from his studies of Weir's and water turbulence into the heart, and come up with something. This is a real hard explanation. Ideally, Leonardo should always get to that mathematical point. Of course, in practice, he was rarely able to do so. But this on its own is amazing testimony. And it so happens I was contacted at Caltech. This was Packard Heart Hospital, and it's a certain scholar of Leonardo all pouring their efforts into the same thing, with an animator called Steve Maher, who is just absolutely spectacularly brilliant, set up his own company on the back of these, subsequently being taken over, but that happens in high-tech. Let me the heart works like a wrung-out towel. That's why it's so open. It doesn't just squeeze, that would be very strong. Keep around the little fellows on the right as well. Thank you very much.